All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Lakshmi Ravi. She is an applied scientist at Amazon. Please join me in welcoming her to our virtual stage.
Hey everyone. Hey everyone, I'm Lakshmi. I've been with Amazon for the last 4 years, and during this time I was working with the NLP teams and causal inference teams in Amazon. So now I'm part of Amazon Music. My journey with Amazon, I learned some important tips and tricks on machine learning practicing. And here I am to talk to you about the tips I've learned from my experience. So this talk is going to be about data collection and synthesization. So let's get started. The motive of my talk here is for machine learning engineers or data scientists, when you have identified a problem space which you have recognized that could be benefited by machine learning model development, and how do you go about it? How do you start collecting the data or synthesizing the data that is required for it? And what are the problems as a general data science practitioners will be facing? And how do you look out for the problems and identify the solutions? So let's do a recap of what is the process of machine learning model development. As we all know, the first step is we look out for related data sources and start the data collection process. The next step is to identify the meaningful features and extract the meaningful features and do the feature transformations on top of it. The final step is to experiment with different machine learning algorithms as depending on the problem space and our problem definition, regression or clustering or any algorithms, and finally release the model into production. So my talk, I'm only going to be focusing on the data collections step and what are the common problems faced there. In the data collection as such, we are going to be talking about what are the skills that is required in data collection, and so what are the problems that come along with it, and so what are the solutions to it. So for the next flow of the talk, let's try to categorize the data into 3 different categories for our own understanding. So the first thing is behavior data. Behavior data represents how a particular customer or a user was behaving while using a product or a service. Feedback data is when, as a product owner or a service owner, when you explicitly reach out to customer asking for feedback. Synthetic data is when a data is not available, when you try to manually create or automatically synthesize a particular data set so that to represent your problem. And let's jump into the first category. What is a behavior data? An example I can think of is, as a YouTube user, if I have to represent my behavior as a data, what are the things that will count as my behavior as? What are the categories of videos I have seen in YouTube? And what is my time spent watching YouTube video? What did I like and what did I dislike? They represent my, how did I like using the product? How did I like this particular service? How my behavior was when I was using the corresponding product or the service. So this is the behavior data. What are the skills required when you have to collect behavior data? We can think of it in 3 steps. The first thing is data ingestion skills. Data ingestion skills is when, especially for behavior data, we can imagine that it is not going to be available in a single source system. It is not going to be available in a single file. The data engineer who you're working with or you yourself will be explicitly doing the data manipulation and extracting the data using SQL operations or any related language, and into collecting the data into a single system so that you can use it for the model development. This is a process on its own. The second thing is domain knowledge. We will be having all sorts of information everywhere. So we have to have some domain knowledge. Either you will work with the product research team or a domain expert to identify what is the useful information you can start collecting as a part of data collection itself. What is the window of time you need to collect? What are the particular uses you are looking to collect? These all come under this category. The second thing is big data engineering. As we can see, when it is behavior data, when it is customer behavior, when it is a data representing the customer's behavior, it is often going to be a very big data set which require distributed systems for processing. So here, for these cases, except for some certain exceptions, we can imagine that it is often going to be a big data for processing. So these are going to be the skills involved when you know your data category is going to be a behavior data. what are the problems that comes with it? As you can see, when you have to ingest the data from multiple sources and you have to manipulate to collect your data into one single file, often the problem is the trade-off between the data source that is easier for you to collect and the data source that is going to be hard for you to collect. Let's take a toy example here. We are developing a machine learning model to forecast what is going to be the weather for the next day. Let's say there is a cache which we can easily collect the data from the last week. And there is an archive data which is hard for us to obtain, which has the data of the last 5 years. So as we can see in this example, the source which is hard to collect is having all the data representations of what we are trying to model. So similarly, for any problem related to behavioral data, whenever it is a data ingestion, you have to be choosing your sources. You have to make sure that the source represents the right data representation of what you're trying to model your problem with. The next problem is big data. Whenever it is big data, the one thing we can know is it often is going to require Spark or Hadoop or any of the data processing techniques for processing the data. So it is not an uncommon practice in machine learning to do a manual analysis when we are starting our problem to understand what are the common patterns, what are the common error patterns. We have done manual analysis in text data, image data, or anything, but as soon as we know it is going to be a big data, we can very clearly see that manual data analysis is not going to help us gain any insight about the data. Even looking at few hundreds of them is not going to give us any meaningful information, and you have to stick to the statistical information. You have to start developing statistical measures, like starting with mean, median, mode, or variance of the data, or like any simple techniques can at least help you start understanding anything about the data set. And these are the problems related to the big data. Next category of data is feedback data. When you develop a product, you often want to know what the customer is experiencing. So you explicitly reach out to customer, hey, how was this particular experience for you? And here I have given two examples of Alexa asking the customer, hey, did I answer your question correctly? And a Lyft is asking me for feedback saying, hey, how was your trip? How was your recent experience with Lyft? Was it good driving, or was it like, did you have any problem or anything? So what happens when we start dealing with feedback data? There are two important skills which will come up when you have to deal with feedback data. So the first thing is developing secure data pipelines. When we are collecting feedback from customer, we want to preserve the confidentiality most of the times, and specifically, and like we have to develop a service that carries the feedback from us, from the what the customer is trying to tell us, to our data endpoints. And the next thing is product research. We have to research and identify what is the appropriate medium to reach out to customers, what is the right way to phrase the question, and how do we make most customers answer to our feedback questions. So these are the problems that comes when it is related to feedback data. So these are the common problems in feedback data. What a data scientist or an ML practitioner is worried about mostly is, how do we make sure there is randomization in the data I'm collecting? So the key of ML data collected should always have is that it is randomized at some level. So it does not have any bias towards any elements. So when it comes to feedback data, sometimes it may be easier to develop a pipeline that is favorable for one or the other group. For example, often collecting feedback after failing to deliver a service is going to always get only negative customer feedbacks. So does it represent the problem correctly is a choice you as a data scientist will have to make. The next thing is collecting always from a specific geographic location or a specific time will have bias towards the time and the experience which the customer was facing at that particular time or at that particular location. And the other thing is getting feedback only from selected amount of customers, or often qualifying few customers and only getting feedback from certain customers is another category. They all could influence a bias in the data set which you are trying to develop a model to represent another problem. So these are the things at the time when the pipeline is developed for collecting the feedback. The data scientist should make sure that there is randomization is a part of the data collection of the feedback data collected, and it does not have any bias towards any of these groups. The one thing you can't work directly is self-selection. When the customer themselves choose to provide data, and not choose to provide the data, that is one thing you have to be aware that is already in the data set, and you have to account for at the time of school. The other category of data is synthetic data. So when we start, one element of synthetic data is that when you don't have the necessary data set readily available to us. So how do you manipulate the data set is the synthetic data. So one thing is we have one example which I worked during my master's was Chrome data set, where the data set was it was developed by reaching out to volunteers by asking them write down a particular math formula from a reference image or a PDF file. So the math formulas were randomly collected from math journals or papers and so on. And the writing volunteers will pen it down for us in an iPad or any smartphone device. So this is an example of manually generating data. The other example is synthetic data generated in an automated fashion. So when we have the text and we have the voice to text synthesizers anyhow, and we are using the synthesizers to develop to generate the audio file for us for the text input we have is another mechanism of automated data generation. So what happens in synthetic data is that identifying the annotating tool or the network, who is going to give us a synthetic data for the given seed value, and are we going to work with manual or automated tools is the first question. The second question is data pipelines. How will you collect the value from the user to here? So what is a seed in a data synthesis? When you know that you are going to be synthesizing the data, the seed value is the input you are giving to the synthesizing people or the program or anything. So in case of the Chrome data set, the formulas we reference from the textbooks can be referenced as seed data, which is used for generating the handwritten math data set. What as a data scientist you will be facing a problem when you know you are working with synthetic data is that what is a seed data? How do I define seed data? And what are the things I should care about my seed data? The first thing is the seed data should have all the data representations in it. For example, in Chrome data set, if all the formulas does it have all sort of symbols in them represented is the first question. And it was manually made sure that the formulas that we take as a reference by having all the symbols in it was made sure. And how do you determine the weight for every sample? It doesn't make sense to go and ask the users to write down the formulas again and again, which we already have synthesized already. But does it have to be directly fed into the model as it is, or some of them needs to be given more weight or more importance than the other ones will have to be made sure at the time after collecting the data. What is a synthesizing variant? The variant is a real-time element that will come into picture, which can affect the data, how it is being synthesized if it is used as it is. So for example, if a data is manually collected, how do you account for the handwriting variations? So when at the time of data collection itself, you're reaching out to multiple people to get multiple variants of the same formula being written. Or when you're doing voice synthesizers, somehow take into account for the accent variations or the male-female voice modulations and everything into account. So thank you.
Wow, Lakshmi, thank you so much. That was amazing. And I know this virtual audience is giving you a huge virtual round of applause. So thank you so much for sharing with us today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.